Okay, maximum multiplication score. So for this problem, we are giving two arrays. So for this array A, it is fixed and it's gonna have at least 4. So we can see that we are giving array A of size 4. So this is for array A. So this size is fixed and it is 4. And for array B, it's gonna be at least 4. Otherwise, we cannot solve the problem because we need to find 4 values inside array B, and the multiplication gonna be the maximum. Yeah. So for the array B, it will be at least 4. Now let's just check what gonna be the limitations for A and B. So A is 4 and B is 10 to the power 5. So basically we cannot solve it by using the brute force, because for the brute force we need to enumerate all the possible values. So definitely it is not possible. So if the brute force is not possible, definitely we're gonna find dynamic programming to solve the problem. So the idea is that we are given two arrays A and B. We can decide to choose the first number. So for example, we're gonna define an index at array B because there will be more elements inside array B, and we can decide we're gonna choose this element or not. Yeah, and here it's gonna be array A. So for the first number, this is 3 and this 2, we can have a decision if we want to choose this value in array B. So it's gonna be 2 times 3, it's gonna be 6. And this 6 is gonna plus some value, so it's gonna be, from here. So this gonna be what left behind for array B, and this gonna be what left behind for array A. As we can see, we make the problem, we make the space, we make the search space smaller. Yeah. So basically, this is a dynamic programming. If we choose 2 and 3, we make the array A smaller, and we make the array B smaller as well. So basically, we make a big problem become a smaller problem. Definitely, we can use a dynamic programming to solve the problem. Yeah. Or we can make another decision. So another decision is if we don't want to choose this index. So if we don't want to choose it, it's gonna still be this subarray because we will not choose this 2. And what left behind for array A, it will be the whole array. But even in this case, our space still becomes smaller, even though A didn't decrease, but B decreased. Yeah. So the dynamic programming idea is we want to decrease A or we want to decrease B. Yeah. So in this case we decrease B, but in that case we decrease A and B. Yeah. So it means for each of the time the space gonna become smaller and smaller until we solve the problem. Yeah. Now let's just use dynamic programming, but here we're gonna use a case with DFS to solve the problem. Yeah. So I'm gonna define an index, and I'm gonna define a value n. So this n gonna be the length of array A because we need to check while there's no element for array A. Yeah. And we need to call the function with DFS from 0 to 0. And let me just prepare a variable. It's gonna be n. Lowercase n gonna be length of array B. So from here we can check that. So if I equals to n, basically we can return a 0 if n equals to 4. It means we consumed all the elements, everything is okay. But if we didn't consume all the elements, so we're gonna return a negative infinity. Yeah. Now we have two decisions. We can decide not to choose anything. So it's gonna be DFS. We're gonna move to the next element, and the capital N gonna be the same because we didn't choose any element. We didn't choose any element. Or we're gonna check this value n. If this n is less than 4, basically it is inside of the boundary. We can choose the element, but we need to check the maximum. So it's gonna be with this result with DFS I plus 1 with n plus 1, and we're gonna decide to choose those two elements, for example 2 and 3. So it's gonna be bi times an. Yeah. So from the beginning this n gonna be 0, so this is gonna be 3 times 2. Yeah. Finally, we can return the result. Now let me just run it to have a check. Now as you can see it works. Now let me submit it. Yeah, as we can see, we passed all the testing cases. Although the speed is a little bit slow, but it is okay. 3 seconds is okay because basically we use the memorization, and in Python it is a little bit slower, but it is still okay for solving the problem, because basically we need to analyze the state and how to move it to the next state. How can we make the state become a smaller state? From the beginning it's going to be bigger, and then it's going to be smaller and smaller until we find the edge case I equal to n, and until we can choose this n less than 4, and we can definitely solve the problem in this way. I think that's all about it. Thank you for watching. See you next time.